Hi, in this video I'm going to go over question 3.2.24 from section 3.2 in fall 2023. It's number 9 in the homework. And here we have listed wait times in minutes of customers at a bank where all the customers enter a single waiting line, and a bank where customers wait in individual lines at 3 different teller windows. So there's bank A, which is the single line bank, bank B, which has individual lines instead. We want to find the coefficient of variation for each of the two data sets and then compare the variation. So you can see here we have the data listed for each, and the coefficient of variation is what we're finding for each. And coefficient of variation, CV, is the standard deviation over the mean times 100 to get a percentage. So this is sample data, so we're finding the sample standard deviation and we're finding the sample mean. To do this, we need to put the data in our calculator. You'll do that by going to Stat and Edit. And you'll see in my list 1, I put the data for A. So I'm just going to write here, list 1. In my list 2, I put the data for bank B. So pause the video if you haven't done this and put your data in, and then we'll move on. Once you have the data in, you're going to go to Stat, over to Calc, and you'll do one var stat, and I want list 1. I'm not using frequencies here, so I'm going to clear the frequencies and then just go ahead and calculate. So for my bank A, I have my mean x bar is 7.18, and I have my sample standard deviation, which is S sub x on my calculator, is equal to 0.50946595513, a nice long number. I can show you where to store that in your calculator. We'll need these in order to find our coefficient of variation. Now we're going to fill in the formula for my coefficient of variation. I'm going to take the standard deviation, I'm going to round it to 4 decimal places, over my sample mean and times by 100. So I'll get 0.5095 when I round to 4 decimal places over 7.18, and I'll multiply that by 100. So we can go ahead and put that in our calculator. 0.5095 divided by, oops, we only need one division sign, 7.18, enter, times 100, enter, and I'll get 7.1% when I round it to 1 decimal place, because 7.096 rounded to 1 decimal place would be 7.1%. So you'll type that in MyLab. For the next part of this problem, we're going to go ahead and find the coefficient of variation in waiting times at bank B, which once again is your standard deviation over the mean, and it's times 100 to make it a percentage. So we're going to go back into Stat, Edit, to get to our list, and we're going to be using list 2 this time. So if you haven't typed in, make sure you type in your data values. I have list 2 as my bank B data values. So now I'm going to go to Stat, over to Calc, and do one var stats, but I'm going to change my list to list 2 because that's where I typed my data in. If you typed it in a different list, that's what you'll put right there. We didn't use any frequency, so leave it blank, and then you can just go ahead and press enter on calculate. So my x bar, or mean, for bank B is 7.13, and my sample standard deviation is 1.7250 if I'm rounding to 4 decimal places. So I will just put that in to my formula, 1.7250 over 7.13 times 100. So we'll put that in our calculator, we'll quit here, and we'll type in our data. 1.7250 divided by 7.13, enter, times 100 to make it a percent. And I get 24.19, rounded to one decimal place, we'll say 24.2%. Now you'll notice that I had to use rounded values in that equation. And in this course, we want to avoid rounding values where possible. For these specific statistics, we can actually access the values in our calculator. So what you would want to do is you'd want to go to Stat, over to Calc, and we'll do our one var stats. And we're using our list 2 because we're talking about bank B, perhaps. So now your calculator has X bar and S stored for you as these values based on your list 2. So if I want to access them, maybe to use this formula, what I can do is I can press the button vars and go down to statistics, because that's where my statistics are stored, and see it's recording right here. And we're going to use S, which is 3, the third item, divide by, and we'll go back to vars, down to statistics, and this time X bar, which is item 2, so I'll press a 2. Enter, and then times by 100. So that's just a little trick you can use to use stored values. You can see we're coming up with the same answer here, but you always want to use stored values over rounded values where you can in your calculations. If I had been doing a calculation and maybe it wasn't a statistics and I wanted to store it, like say this calculation here, I can press STO and then press alpha and pick a letter to store it at. Maybe I want to store it at alpha D. Enter. And then if I wanted to use that value later in a calculation, this is totally out of context of the problem I'm just showing you. If I had the number 635 and I needed to use a value I had before, maybe I had stored it in D, I'll press plus alpha D and it will add those numbers together. So that's really 635 plus 24.19. 371777 and so on. So you can always use store values in your calculator using STO. You can overwrite it the next time you do it. You can replace it. It doesn't have to be stored at D. It can be stored at alpha and then any of those green numbers. Okay. The last part of the problem is asking you whether there's a significant difference between the coefficient of variations for bank A and bank B. We can see that the coefficient of variation for bank A is 7.1%, where for bank B, it's 24.2%. There's a big difference in those numbers. So I would say that bank B has considerably more variation and bank A has considerably less variation. I hope you found this helpful. You can use this as a model for your problem if you have slightly different numbers. And please let me know if you have any questions. I'm here to help you. Bye.